All right, thank you so much. Let's look at this second problem of the day, and how do we use what I've learned so far to solve these problems. Now, interestingly, we already have the general solution for this particular uh, uh, um, ODE, right? So if you remember the solution we had for the previous problem, we had such a result. Now, how do we move from here? In this particular problem, what has now happened to the problem is that we just transformed it. How did we do that? By including uh initial value problem. I mean, including a boundary condition, okay? Now, um in this particular one, what is going to happen is that since now our solution is now going to exist within a particular region, we have to invoke that restraint on the solution. Okay. Remember that we already have the general solution as this, but now being given this initial value problem. How do we handle that? Okay. So it's important that um, the the solution also satisfy that. Okay, the solution also satisfy the initial conditions, which is of this form. Okay, it's important that we also do that. Okay, all right. So how do we do that? So let's look at the solution that we already have. So the solution we have, it was y of x equal to c1 multiplying a to the power 2x plus c2 multiplying a to the power minus, is it minus 3x, right? Yes, minus 3x. Okay. Now, how do we move from here? Now, to satisfy the initial conditions, we require that. Now, what it means is that now my over here, so when you look at the first one, the first condition, let me use a different pencil. So when you look at the first initial condition here, we see that y of 0 equal to 1. Okay, so which means that wherever I see x in this particular um, solution, I replace wherever I see x, I replace it by 0. Okay, so I have my y of 0 equal to what? C1 multiplying. Now e to the power this plus C2, we should equate it to 1. Okay, now e to the power 0 is what? It's 1, right? So you're going to have our C1 plus C2 being equal to 1. So let's call this equation 1, okay? And then let's look at the second, let's call the second condition. The second condition requires that y prime of 0 equal to 1. So which means that we have to differentiate this, okay, to be able to apply that condition. We have to differentiate the solution that we had. Now, by differentiating the solution y of x, so which is y of x, by differentiating this particular solution, we're going to have what? When you differentiate e to the power 2x, what do we get? So we drop the power, we drop the coefficient of x, which is 2, right? So we're going to have 2c1 multiplying this, and we drop that. That gives us what? 3c2 e to the power equal to what? Okay, so that's what we have, okay? So now that we have this second the first derivative of the solution, now we can now invoke the initial condition on this, okay? So it means wherever I see x replaced by 0, then you equate the result to 1, right? So that's what we are going to do here. So it means that my y prime of 0, which means wherever I see x, are replaced by 0, okay? So by doing that, you should have 2c1 minus 3c2 being equal to what? 1. Okay? So this now becomes equation 2, okay? Now by solving equation 1 and equation 2, solving for equation one, solving equation one and equation two simultaneously. Now we should have our C1 should be equal to what? Who can guess? C1 should be what? Should be 3 on 5, and then C2 should be what? 2 on 5. Okay, that is if you do. Now it means that now our the required solution of the initial value problem now becomes my y of x equal to what? Or do we have it here? So we are just plugging back. We are just plugging it back into this. Okay. So my so we're going to have so we're going to have 3 on 5, then 2 on 5 e to the power minus 3x. So, this is the the solution to the initial value problem. Okay, so let's take note. Thank you so much. And at this point, if you have not subscribed to our channel, please do so. And let's continue to build a community that is free from the mindset that math is difficult. Thank you so much.